Why, hello all. Today we'll be discussing slope and rate of change. All right, exciting stuff. You've probably done a good amount of stuff involving slope, and I'm not going to get a ton into every little detail because we're going to be talking about it over the next few days as well. But the first part is that with slope, what is it? Well, I'm going to write it down. Slope. We'll also see the letter M with it a lot. Rumor has it was the French word for slope. Rene Descartes, he was a Frenchman. The Cartesian plane, that's just a normal graph that you would put. That's where the rumor came of why we use the letter M. Really, we don't have any real idea. But when we're thinking about slope, the most common way to think about it is rise over run. And another way to think of it, and the equation that we're going to often use is y2 minus y1 over x2 minus x1. Now, the twos and ones, really, it's just a placeholder for them. Another thing we'll put is the triangle means change. So I'm going to put that over here. So it's a shorter way to say the change in the y over the change in the x. What's the biggest mistake most people make? If you said that people put y's on the bottom and x on the top and they flip it, you would be right. That's the biggest mistake most people tend to make, is that they flip them, because most things we do, we have x's then y's. This, we have the y on top, the x on the bottom. Rise, up and down, over run, left and right. So if I were given 2 points like 2, 3, and -7, 5, now, you can label these if you want. This is where the x1, y1, and x2, y2 come in. They're just placeholders. Okay, x and y, in a coordinate, you have an x, then a y. These are both 1 means it's from the same coordinate, x and y. The 2 means that it's from the same coordinate. So if I look at the y2 minus y1, we're saying that I would subtract the y's, 5 minus 3, over -7 minus 2. So 5 minus 3 is 2. -7 minus 2 is -9. We always check if you can simplify. In this case, I cannot. So my answer is you could leave it as 2 over -9. You could put a negative in front and go 2 9ths. You could have -2 over 9. Because if I were to take these points, and let's say I go to 2, 3, 1, 2, 1, 2, 3, okay, and I went up 2, and then that would mean left 9. I didn't have enough spots here, but it'd be up 2, left 9. Or another way to think of it would be if it was -2 over 9, down 2, and to the right 9. But you could see that that would all end up being on the same line. So it all still works out. So that's one way. It doesn't matter where the negative is, just a matter of thought. Does it matter which way you subtract? No, as long as it's the y's over the x's and you do the same first, left to right or right to left. So for example, here I could have also done 3 minus 5 over 2. Now this is where you got to be careful. It would be minus -7. The minus in the equation is built in. So if you have a negative, you have to include that negative in there. So in this case, you'd see 3 minus 5 is -2. 2 then plus 7 is 9. So it doesn't matter which way you do it, left to right or right to left, you're going to get the same answer in the end with it. So you just have to be careful of that you're doing the y's on top and the x's on the bottom. Okay, so another example. What if I had 0, 3, and 5, 0? I picked this one out and I put the zeros in, but basically this is the y-intercept and the x-intercept. So it doesn't matter, again, which way you go. Most of you are not anymore going to do y2 or x1, y1, x2, y2. You're not going to do that anymore. You'll just go, okay, I like left to right. Just make sure you have the y's first. Sometimes people underline, the y's, circle the x's. So I know I'm looking at different numbers or the different points in there. 3 minus 0, and then I have to go left to right. I'd go 0 minus 5. So I'd get 3 over -5. Can I simplify that? No. What if you did the other way? Last one I'll do both ways. I'd go right to left. Okay, 0 minus 3 over 5 minus 0. You'd get negative 3 over 5. Same thing. Negatives in a different spot. That means first this one you'd go up 3, left 5. This one you'd go down 3, right 5. But it all turns out the same when you're graphing those points on a line. Okay. Now, what does the rate of change part mean? When I have rate of change, this basically means I'm just going to have units involved with it. Okay, so if you think of things that have, you could graph as slope is on a line, but like miles per hour, dollars per hour, gallons per mile, or miles per gallon. It usually just throws a unit on there. And we're going to get into word problems later on in this chapter, or this section, lesson, whatever we want to call it. But that's where you'll see more with rate of change, is just adding units on them. Let's just look at another example with some more negatives. Negative 2, negative 5, and let's say we have negative 10 and negative 4. So if I'm going from left to right, the y's first, negative 5 minus negative 4 over negative 2 minus negative 10. So in both of these, I have a negative and a negative turn into a positive. Negative and a negative turn into a positive. Negative 5 plus 4 is negative 1. Negative 2 plus 10 is positive 8. I cannot simplify that, so I still have negative 1 over 8. Okay? One more I'm going to do just to get one where we can simplify. Let's say I have 2, 2, and go 12, 10. So with these also, be careful, 2 and 2, they're both the same, y and x obviously, but make sure I go, this one I'm going to go right to left, doesn't matter. So I have 10 minus 2, then I have to do 12 minus 2. So 10 minus 2 is 8, 12 minus 2 is 10. So when I say we're looking to simplify, 8 over 10 is not a simplified fraction. I look what goes into both 8 and 10, and I could divide both by 2, so I end up with 4/5. That's the right answer. We are always looking to write slope in its most simplest form. That is horrible English right there, but you get the point. Okay? And no pun intended. That was funny. We're talking about points and you get the point. All right. Enough math dad jokes. Slope, rise over run. Y2 minus y1 over x2 minus x1. Okay, it's just you're subtracting the y, subtracted the x's, same direction. Change in y over change in x, however you want to think of it. Make it work for you.